Yo, what's up, guys? This is Isami. Your boy is back here again. We'll be going more deeply into web app security. Today, I'll be discussing a topic which is one of the OWASP top 10 vulnerability, which is the cross-site scripting, the XSS. First, I will be explaining cross-site scripting in this video. Then, in my following video, like after dropping this video, I'll be dropping another video showing you how to probably exploit or hunt for these vulnerabilities and giving you let's say an example based on labs on how to check for XSS vulnerabilities. So let's get started. So first off, cross-site scripting. Cross-site scripting is actually let's say a type of security vulnerability typically found in web applications. It allows attackers to inject malicious scripts into web pages viewed by users, and these scripts can steal your session tokens, redirect users to malicious websites, or perform other harmful actions. Then we have different types of cross-site scripting. So cross-site scripting is categorized mainly into three types. We have the stored cross-site scripting, which is the persistent type of cross-site scripting, the reflected XSS, which is the non-persistent one. We have the DOM-based XSS, which affects the document object model of a web page. For the stored XSS, which is the persistent one, a stored XSS, this occurs when malicious script is permanently stored on target server, such as the database, forum posts, or comment field. Typically, any area where users can like interact with the website. Let's say profile page, yeah, anywhere users can view your information or view a comment or view a text. That's where stored XSS is being implemented mostly, or is being exploited from mostly. So when a user visits here, just like I said, when a user visits the page, the script is served as part of the page content and executed in the user's browser. Let's have an example of cross-site scripting. Let's say an attacker creates this kind of payload, like creates a payload using the script tag, adds it probably on the comment section for other users to view. So once the user views this kind of payload, using this one as an example, because typically in the real world this kind of payloads don't really work anymore, because we have a lot of protocols which guides against this kind of, like, which protects the web pages against this kind of payload. Something like the WAF, that's the web application firewall. Once a user views, let's say views or clicks on, depending on how the payload is crafted, if it's a click type of payload, but this one is affecting the script tag from the comment section. Let's say it is put in a comment section where users can interact, as I've said earlier. So once it is put there, then this is like stored, this payload is stored in the database. So when another user views the comment, the script executes in their browser. So by then we have whatever is being crafted in the payload, probably to deliver a specific malicious link or redirect user or steal user token, is going to be activated by the user viewing this comment. So the next one, we have reflected cross-site scripting, the non-persistent XSS. So this occurs when malicious script is reflected off a web application to victim's browser. This type of attack typically involves the victim clicking a specially crafted link, submitting a malicious form, or visiting a URL that includes a malicious script. This kind of cross-site scripting reflects back on probably the let's say the server side of the web page. So let's have an example. If this is an example of a specially crafted link for reflected XSS. This one is targeting the search button, like the search query button or the search query of a website. So here now we have the script, this script alert XSS. So this is the payload on the search query part. So once this is served or sent to a user, the server reflects the script back to the search results page. When the victim clicks the link, the script executes in their browser. So that's just how reflected XSS work. Once a link is crafted and it is sent to a victim, so the payload reflects back instead of being saved. Like instead of being, it's something like, let's say the stored now, the stored is saved in the database, but reflected is not being saved. It's just being reflected back in the search results, because this one is targeting the search results, so it reflects back on the search results page. So when the victim clicks the link, the script executes in their browser. So let's move to the DOM-based XSS. This occurs when vulnerability exists in the client side. This one is not the server side. This one is the client side, which is working like on the document object. So this occurs when the vulnerability exists in the client side code rather than the server side code. This means the malicious script is executed as a result of modifying the DOM environment of victim's browser. What that means is, as I've explained earlier, is just modifying the document object, something like the JavaScript side of a web page. That's where it handles the document object model. So let's have an example of that. So in the DOM-based XSS now, so this is an example of the payload. This is the link. We have the URL link, then attached. So one thing I noticed about DOM-based XSS is that they mostly have either an apostrophe, an hash, mostly an apostrophe or an hash before the payload is being inserted, which mostly signifies, let's say, ending, like a closing tag or a closing for the previous URL or for the previous request from the URL side. So then the payload follows, something like this. After this URL, we have an hash, which is to close the previous URL. Next, we have the payload, which is the script, alert, attack, blah 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 blah. So let's say in the real world scenario now, you have to impute your own specially crafted payload based on how the website functions or what the website accepts. The client side JavaScript code processes this URL fragment and injects it into the page. So this payload is being executed in the, let's use this var side as an example, which is the document object side. Like you can see, document.getById. To understand this kind of vulnerability, like to exploit this kind of vulnerability, you must have a little knowledge of JavaScript. So this side is where the payload is being executed. So once the script executes, like once the script gets to this DOM side, it executes on the victim's browser. Those are the major three types of cross-site scripting we have. But then we have two other cross-site scripting which are mostly not mentioned, as like they are not categorized as the major types of XSS we have. So those are the blind XSS and the stored type of XSS. Blind XSS, this is similar to stored cross-site scripting, but the attacker does not see the immediate result of the attack. Just like the name implies, it is not seen immediately. So it is seen by the, let's say, the administrator of the website, or let's say from the control panel side of the website. So whoever is viewing probably a request from the user or seeing a form from the user, that's where script or the payload is being executed. So this type of XSS often targets, just like I've said earlier, it targets the administrators or other privileged users, people that have the high rank role to a website, something like the control. So the malicious script is stored on the server and executed in the context of a user with higher privileges when they access the affected area of the application. So we have an example. Let me show you an example. The example of blind XSS. So this is the payload, which is implementing this script tag part of the HTML. So in it is, this one is using the let's say new image source. So this one is trying to steal a cookies. This kind of payload is trying to steal cookies by altering the image source location of the website. So using this script tag. So the script is like, once this payload is crafted, so and let's say it is sent to I'm trying to look for an example of where you can implement a blind XSS. Let's say a feedback, or a feedback. It can work on comments, so just where like places where other users won't see, just the admin is going to view, something like the database. So yeah, that's where it is executed. So the script is stored in the database, just like I've said. So an administrator views the feedback and the script executes, sending their session cookies to the attacker's server. So that's how blind XSS work. Next, we have the self XSS. This one is mostly done on your own side of the website, like on your own by, let's say you open the source code of a website. So let me just go into the definition. This occurs when an attacker tricks a user into running malicious scripts on their own browser, often through social engineering. This is mostly done through social engineering. This type of attack typically involves convincing the user to copy and paste scripts into their browser console. So that's just like I've said earlier, that's how a self XSS works on your own side, like on, let's say, the victim side of the browser. You know, you're using social engineering for the self XSS. So let's say you send this kind of message with the link embedded in the message to a victim. This, please copy and paste the following code into your browser to get free credits. You know, people want free stuff now. So once you give them this kind of message, you can craft your own message based on but it is mostly done through social engineering. And this kind of XSS is mostly ignored. It has this sort of low impact, so most organizations ignore this kind of vulnerability when submitted to them. So let's say you send this message, as I've said. So once this payload is sent to the victim, and the victim loads up this payload, once they get to their browser site, so script alert, you have been hacked. So something like this one is just, this is like a very straightforward example. So the victim copies the script into their browser console, executing the malicious code immediately. These are kind of the types of cross-site scripting we have. So this video is just to explain the types of cross-site scripting we have. So in my next video, I will be taking them one after the other, from the DOM, the reflected, blah blah blah, like that. So I'll be taking them one after the other with practical examples, probably from Portfigure or any other labs I have, and how to execute the payloads, and where to put the payloads, and how the payload functions, and where exactly to hunt for the types of cross-site scripting. I hope you enjoyed this video. Make sure you drop a like and press the subscribe button. So stay tuned. I'll be dropping the next video soon. Bye guys.